Hey everybody, I'm going to show you how to complete the element cards. And so on the element cards, there's 3 sheets of paper. They look like this. Notice one sheet starts with chlorine across the top. The next sheet starts with hydrogen across the top. And the last sheet is half blank. So that should be easy to tell that there are 3 distinct different sheets. Make sure you have one of each. What you're going to do with the element cards is you want to take your periodic table. And on your periodic table, according to the notes we watched the other day, we're concerned about the staircase. Everything to the right of the staircase is a non-metal. Now if you notice on my key right here, non-metal is orange. And so you can see that over here I got some orange to represent non-metal. So are the rest of these. We colored the halogens and the noble gases a different color, but they're still a non-metal. So everything to the right of the staircase is a non-metal. Everything to the left of the staircase is a metal. Now, even though we colored the alkali metals yellow and the alkali earth metals brown, the most of the metals are blue. So we're going to use blue to represent metals. We're going to use orange to represent nonmetals. The only nonmetal that is to the left is hydrogen. So always remember, hydrogen is all the way over here. It is a nonmetal. It just also happens to be to the left of the staircase. So again, one last time, everything to the left is blue. It's a metal. If it's to the right, it's orange and it's a nonmetal. So I now look at my cards. And I start and I want to use blue and orange, and you can use marker, color pencil, crayon, doesn't matter. And so I want to go through, and chlorine, which is a non-metal because it's located to the right of the staircase, I want to color it orange. And so I'm going to color my chlorines orange real quick. It doesn't take very long at all. There we go. And I will continue to color any other ones on here orange that are non-metals, like fluorine, for example. Fluorine is also located on the periodic table to the right of the staircase. It's located right here, which is to the right of the staircase, so therefore I'm going to make it orange to represent that it's a non-metal, and I would color fluorine. Then I want to go and I want to color all my metals blue. So on here I've got potassium, which is K. Potassium's all the way over here, and so it's a metal. And so again, we're using blue to represent metals. And I would color in potassium blue. And I would do the same with other metals. I've got aluminum, sodium, magnesium. Those are all metals on this page. And I do the same for all 3 pages. Now, once I've colored in my non-metals orange and my metals blue, I can set those to the side. I'll no longer need them. And now I can use any color that I like to represent the valence electrons. So chlorine, for example, it has 7 valence electrons. I'm going to use red to fill in those 7 valence electrons. And then I would do the same for the next chlorine. I would make sure I fill in 7, and I would also use red. And I would do the same for the next one. Then I can come over here to potassium, and I can pick any other color now that I want for its valence electrons, but potassium is members in group 1, so it only has 1 valence electron, and I would use yellow or whatever color you want to use for that, and then I would move to the next one. So I would continue to fill in the valence electrons. Just if there's more than one of the element, keep the valence electrons the same color. Once I've done all 3 pages, I'll notice on the last page it's got some blank ones. So these are for any element that might be missing. So if for some reason you lose one or you need to make one that doesn't exist on here, that's what the blank ones are for. So you can just save those for later. All right, the next thing I do is I cut them out. So once I have them all cut out, I've got the blue and the orange, and then I've got the valence electrons. I cut them out, and I want them to be in the shape of a stop sign. So notice how I've got those in the shape of an octagon, whereas these are not. Right, so it's real simple, right? To get in the shape of an octagon or a stop sign, I just cut the corners, and the closer you cut it, the easier it's going to fit for you. So on this part, I want to be nice and neat because they're going to fit a whole lot better for me when it's time to work with them. So there we go, I got that one, and then I get this one. And once I am done cutting, all the trash goes in the trash can, not in the floor, not left on the table. You put trash in the trash can. So there we go, I've got a nice octagon. Hey, look, all my trash. I can grab a trash can and whoop, nice and easy. There we go, I got my table all cleaned up. Now I take my work from the other day. This is section B, ionic bonds. And the first one on there, example B1, is sodium chloride or sodium and chlorine. So I want to take my sodium and chlorine, and now I can see that chlorine needs 1 electron, sodium has 1 electron, and it can fit together just like that. And I have essentially made salt, or sodium chlorine, and I can set that one to the side right there. And the next one on here is magnesium iodine. So I got magnesium, and I got my iodine. Magnesium has 2 electrons to give away. So it can give away the first one right there to that iodine. But of course I would need a second one because I need to bring it in so that the second one can go right like that. They might overlap slightly, but now I've created magnesium iodine. I would continue to make my other 4 examples for my total of 6 that I have, and then I can snap a picture of this with my Chromebook and I can turn it in through Classroom under the assignment. Whenever I'm done with my cards, I want to be able to keep them without losing them. I have a box of sandwich bags, Ziploc bags. I can take all of my cards, put them in these Ziploc bags so I do not lose them. There we go. And I can keep that in my folder. All right, guys, that is the lesson for the element cards.